Ford 300 Inline 6. The Ford 300 Inline 6 is one of the most legendary long-life truck engines ever built in North America. Introduced for the 1965 model year and remaining in F-Series pickups, E-Series vans, and work trucks through the mid-1990s, it earned its reputation not with big horsepower numbers, but by refusing to die. Farmers, utility fleets, contractors, and small businesses all trusted the 300 because it would start every morning, pull hard all day, and still be ready to work the next week. Displacing 300 cubic inches, or 4.9 liters, it was a big inline 6, and that size worked in its favor. The long stroke design delivered strong, low-end torque right off idle, which made it perfect for towing, hauling, and slow-speed work where most engines suffer. Ford engineers deliberately kept the specific output low, so the 300 rarely operated anywhere near its mechanical limits. Inside, everything was built with durability in mind. A heavy cast-iron block, a cast-iron head, 7 main bearings, chunky connecting rods, and large-diameter bearings that spread loads over generous surfaces. A simple pushrod valve train with 2 valves per cylinder rode on long-wearing timing gears instead of a chain or belt, eliminating another common failure point. Early engines used a straightforward one-barrel carburetor. From 1987 onward, Ford added multi-port electronic fuel injection, which improved drivability and cold starts without complicating the basic architecture. There were no turbochargers, variable valve timing systems, or exotic materials to worry about, just big, conservative components designed to keep turning. Mechanics loved the 300 because it was easy to service in the real world. Spark plugs, the water pump, alternator, and fuel pump were all accessible in a truck's engine bay, and most jobs could be handled with basic hand tools in a driveway or farm shop. The engine tolerated less than perfect maintenance, better than most, and owners who were late on oil changes or occasionally overloaded their trucks usually didn't kill a 300. Real-world mileage is where the engine's reputation becomes almost mythic. Hundreds of thousands of F-Series and work trucks have recorded 300,000 to 400,000 miles on original internals, and there are many credible stories of engines reaching 500,000 miles or more before major work. A few well-documented examples in fleet and industrial service have even approached the million-mile mark when cared for properly. The formula behind the Ford 300's success was simple: big displacement, low stress, heavy materials, and a design that never chased fashion or cutting-edge technology. Decades after Ford ended production in 1996, the 4.9-liter inline 6 still has a dedicated following, and used engines are snapped up quickly for project trucks and farm rigs. In an era of complicated powertrains, the Ford 300 inline 6 stands as proof that a simple, overbuilt engine can outlast almost anything around it. Toyota 22RE. The Toyota 22RE is one of the most respected, long-life 4-cylinder engines ever built, especially among truck and 4x4 enthusiasts. Introduced in the early 1980s and produced into the mid-1990s, it powered Hilux and pickup models, early Forerunners, and some Celicas during the period when Toyota's reputation for bulletproof reliability really took hold. On paper, the 22RE was nothing exotic: a 2.4-liter inline 4 with a cast-iron block, aluminum cylinder head, and a single overhead camshaft operating 2 valves per cylinder. What set it apart was the way Toyota combined conservative engineering with just enough modern technology to make it efficient and easy to live with. The 22RE used a timing chain rather than a belt, eliminating the need for periodic belt changes and reducing the risk of sudden timing failures. Its compression ratio and ignition timing were tuned conservatively, and the bottom end featured stout crank journals, thick connecting rods, and robust bearings designed to handle long-term abuse. Electronic fuel injection, standard on the 22RE, was kept deliberately simple and reliable. The EFI system used straightforward sensors and hardware that tolerated heat, dust, and age better than many contemporary designs, which made these engines ideal for remote regions and off-road duty. Depending on year and application, the 22RE produced around 105 to 115 horsepower and roughly 135 to 140 pound-feet of torque, modest numbers that helped keep internal stresses low. Owners didn't buy these trucks to win drag races. They bought them because they would start in freezing winters, idle all day on job sites, and crawl up rocky trails without complaint. In harsh real-world service, the 22RE earned its legendary status. With regular oil changes and basic cooling system maintenance, it is common to see these engines reach 300,000 miles on original internals, and many documented examples run well into the 400,000-mile range. The design is also friendly to do-it-yourself mechanics. Spark plugs, injectors, filters, and accessory drives are easy to access, and the engine bay of an older Toyota truck leaves enough space around the 22RE to work comfortably. Parts availability remains excellent thanks to huge global production numbers and strong aftermarket support. While a severely overheated 22RE can still warp a head or blow a gasket, like any aluminum-headed engine, it generally tolerates hard use, rough roads, and less than ideal fuel without quickly failing. Toyota's formula was straightforward: a strong cast-iron block, simple valve train, durable fuel injection, and calibrations that favored longevity over power. Decades after production ended, 22RE-powered trucks are still prized in places like North America, Australia, and the Middle East, where reliability can matter more than speed. For many enthusiasts, the 22RE is the engine that best represents Toyota's old-school reputation for building vehicles that just keep going. Mercedes-Benz OM617. The Mercedes-Benz OM617 is one of the most famously overbuilt diesel engines ever produced. Introduced in the 1970s and used through the mid-1980s, it powered Mercedes sedans, coupes, and the iconic W123 chassis. Its reputation was built not on performance, but on engineering so robust that the engine often outlasted the car itself. The OM617 was a 3-liter, 5-cylinder diesel with a cast-iron block and a cast-iron head. Every major component was thick, heavy, and designed with enormous safety margins. That meant the engine ran cool, stable, and stress-free, even under hard use. Mercedes built it with the expectation that it would be used in taxis, fleet service, and harsh conditions, so reliability was not a priority. It was the entire mission. One of the OM617's defining features was its mechanical fuel injection system. It didn't rely on electronics, computers, or sensors. Fuel delivery came from a Bosch inline injection pump that became legendary for surviving extreme temperatures, dirty fuel, and abuse. As long as the injector pump received clean oil, it kept working. The engine produced modest power, usually between 80 and 125 horsepower, depending on turbocharging, but it delivered steady, low-end torque and remarkable smoothness for an inline 5. The turbocharged versions gained popularity in the United States, especially in the W123 and early W126 models, where they offered respectable acceleration while maintaining diesel durability. What truly cemented the OM617's legacy was its real-world track record. Around the world, these engines powered taxis that routinely surpassed 500,000 miles. Many documented examples reached 1 million miles without major internal repairs. In some regions of Africa and the Middle East, OM617-powered W123s are still used as daily transportation more than 40 years after production ended. The engine tolerated poor fuel, infrequent oil changes, and extreme climates. Its cooling system was simple yet effective, and its oil capacity was large enough to protect the internals even when maintenance was neglected. The bottom end was nearly indestructible, with forged components and oversized bearings designed for long service intervals. Another advantage was ease of repair. The OM617 could be serviced with basic tools, and its mechanical simplicity meant that skilled mechanics in remote areas could rebuild or maintain it without specialized equipment. Replacement parts became widely available and inexpensive, helping these engines stay on the road decade after decade. Mercedes engineered the OM617 with a philosophy that reliability was non-negotiable. The result was an engine that became a global symbol of durability. Even today, enthusiasts seek out OM617-powered cars because they know the engine will keep running long after most modern vehicles are gone. The OM617 didn't just last a long time, it created one of the strongest reputations for longevity in automotive history. Chrysler Slant 6. The Chrysler Slant 6 is one of the most durable gasoline engines ever built in the United States. Produced from 1960 through the late 1980s, it earned its legendary reputation not through power or refinement, but through an ability to run under conditions that would destroy most engines. For taxis, farmers, delivery fleets, and demolition derby drivers, the Slant 6 was the definition of indestructible. The defining feature was its 30-degree tilted cylinder layout, the slant that gave the engine its name. This angle was not originally intended for longevity. It was designed for packaging, allowing Chrysler to fit a longer intake manifold and a lower hood line, but the design accidentally created one of the best-oiled engines of the era. Gravity helped the oil return quickly and evenly, preventing starvation during hard cornering, steep climbs, or long periods at high revolutions per minute. The engine came in 170, 198, and 225 cubic inch versions, with the 225 becoming the most famous. These engines used a cast-iron block, cast-iron head, forged crankshaft, and heavy-duty internals. Everything about them was oversized, overbuilt, and designed with huge safety margins. The bottom end was particularly strong, with thick bearings and a crankshaft that resisted wear even after hundreds of thousands of miles. The Slant 6 was not powerful. Most versions made between 100 and 145 horsepower, but it was willing. It idled smoothly, pulled with reliable torque, and tolerated abuse that would destroy lighter, more sophisticated engines. Taxi companies routinely logged 300,000 to 500,000 miles on these engines, often without ever removing the cylinder head. Farmers ran them low on oil, cooked them in the summer heat, or used them as stationary power sources. They still ran. The engine's simplicity was part of its magic. A carburetor, mechanical fuel pump, and basic ignition system meant it could be repaired anywhere. Spark plugs were easily accessible. The timing chain almost never failed. The cooling system rarely clogged. And even when the engine overheated, the cast iron head resisted warping, preventing the head gasket failures that plagued many competitors. The Slant 6 also became a favorite in demolition derbies. Drivers discovered that it could run with cracked radiators, bent frames, and oil leaks. Even with no coolant, the engine often kept running long enough to finish an event. Few engines could take that kind of punishment. Chrysler eventually replaced the Slant 6 as emissions rules tightened, but its legacy remains unmatched. It was not advanced. It was not quick, but it lasted forever. The Chrysler Slant 6 stands as proof that durability comes from simplicity, heavy materials, and reliable engineering, and few engines ever matched its reputation for staying alive when everything around it failed. Detroit Diesel Series 60. The Detroit Diesel Series 60 is one of the most respected heavy-duty engines ever built. Introduced in the late 1980s and produced into the 2000s, it became the backbone of the North American trucking industry. Its reputation was built on long life, simple design for its class, and the ability to accumulate miles that most engines could never approach. Million-mile engines weren't rare, they were expected. The Series 60 came in displacements of 11.1, 12.7, and later 14 liters. All versions shared the same core philosophy: build a large, inline-six diesel with conservative engineering and components designed for continuous, high-load operation. The architecture was straightforward and robust. A cast-iron block and head, massive crankshaft, industrial-grade bearings, and thick cylinder liners all contributed to longevity. Everything was built to handle thousands of hours of high-compression diesel combustion without fatigue. One of the Series 60's biggest innovations was the Detroit Diesel Electronic Control System, DDEC, one of the first successful electronic engine management systems in a heavy-duty diesel. DDEC was designed to improve fuel economy, reliability, and emissions, while still keeping the engine easy to service. For its time, it struck the perfect balance between modern control and practical simplicity. Diagnostics became easier, fuel use improved, and the engine maintained its rugged character. The Series 60 quickly gained a reputation among fleet operators for consistency. Many engines surpassed 1 million miles without major work, and it was not unusual for carefully maintained trucks to reach 2 or even 3 million miles before an overhaul. The engine was also known for its strong fuel economy compared to other big diesels, which helped trucking companies control costs over long distances. Maintenance accessibility was another part of its success. The inline-six layout left plenty of room for mechanics, and the components were designed for longevity rather than extreme performance. Oil changes, injector replacements, and routine service were straightforward. The wet sleeve design allowed rebuilds without removing the engine block from the chassis, reducing downtime and cost. The engine's reliability made it a favorite in long-haul semis, buses, and industrial applications. It handled cross-country trips, mountain passes, and extreme heat with the kind of consistency that owners trusted. Drivers often reported that the engine felt strongest between 1,200 and 1,600 revolutions per minute, a range where the Series 60 could run endlessly without stress. As emissions regulations tightened in the 2000s, the Series 60 era came to an end. Newer engines became more complex, using after-treatment systems and high-pressure common rail injection, but the legacy of the Series 60 remains unmatched. For decades, it proved that heavy-duty diesels didn't need complexity to be world-class. They needed solid engineering, smart control systems, and components built to last millions of miles. The Detroit Diesel Series 60 is still widely considered the greatest million-mile commercial engine ever built. Volkswagen Type 1 Air-Cooled Flat 4. The Volkswagen Type 1 Air-Cooled Flat 4 is one of the simplest and most resilient engines ever put into mass production. Originally developed in the 1930s and built in various forms into the 2000s, it powered the Beetle, Type 2, Microbus, Carmen, Ghia, Thing, and countless industrial and kit car applications around the world. Displacement for the classic Type 1 engines ranged from just over 1 liter to 1.6 liters, with power outputs typically in the 25 to 60 horsepower range depending on year and configuration. The layout was a horizontally opposed four-cylinder, or boxer, which naturally balanced engine vibrations and allowed a very compact package mounted at the rear of the car. What made the Type 1 truly distinctive was its air-cooled design. There was no radiator, no water pump, no coolant hoses, and no antifreeze to leak or boil away on a steep climb. Cooling air was supplied by a belt-driven fan and routed through a carefully shaped shroud that forced air over the fin cylinders and cylinder heads. This eliminated a whole set of common failure points and let the engine survive environments that would test more complicated water-cooled designs. Construction was straightforward, but clever. The crankcase was cast from a lightweight magnesium alloy, which kept weight low over the rear axle, while the 4 separate cylinder barrels were made of cast iron for durability. Each bank of cylinders used a single aluminum cylinder head that spanned 2 cylinders, with aluminum pistons and simple overhead valves driven by push rods from a central camshaft. Fuel was delivered by 1 or 2 simple carburetors, and lubrication relied on gravity-assisted oil return paths that could cope with long periods of storage or less than perfect maintenance. For owners and mechanics, the engine became famous for its serviceability. Valve adjustments, ignition work, and carburetor tuning could be done with basic hand tools, often by amateur enthusiasts. The entire engine could be removed from a Beetle in under an hour, making clutch replacements and rebuilds straightforward even for small shops. In real-world use, the Type 1 Flat 4 proved incredibly durable. In countries with rough roads and limited repair infrastructure, air-cooled Volkswagens became the default choice for taxis, delivery vehicles, and family transport. Engines were often rebuilt cheaply and sent back out for another long tour of duty. Off-road racers and desert enthusiasts also embraced the VW Flat 4 because it could survive extreme dust, heat, and sustain high revolutions per minute without the risk of coolant loss. Oil leaks were a well-known quirk, but they rarely meant the engine was in danger. Most owners simply topped off the oil and kept driving. Today, the Volkswagen Type 1 air-cooled Flat 4 is remembered as an icon of minimalistic, durable engineering, proving that a simple, well-thought-out design can keep people moving for generations. General Motors 3800 V6. The General Motors 3800 V6 is one of the most reliable and longest-lasting gasoline engines ever produced in North America. Introduced in the early 1960s and refined over multiple generations, it matured into a power plant known for simplicity, low operating costs, and exceptional durability. By the 1980s and 1990s, the 3800 had become the engine of choice for millions of GM sedans, taxis, police vehicles, and fleet cars. The final versions, known as the Series 2 and Series 3, cemented the engine's legacy. At 3.8 liters, the 3800 used a naturally aspirated or supercharged 90-degree V6 layout with pushrod valve actuation. While overhead cam engines grew more common, GM stuck with a simple cam in block design that was easy to service and inherently durable. The architecture resulted in fewer moving parts, lower production costs, and less complexity than competing engines. A cast iron block, iron heads, and a stout rotating assembly contributed to longevity. The block design used thick cylinder walls and deep main bearing webs, while the crankshaft and rods were sized generously for the power output. The engine produced between 165 and 240 horsepower depending on the version, but more importantly, it delivered smooth, abundant torque at low revolutions per minute. This meant the 3800 rarely had to strain, keeping internal wear minimal over years of daily use. GM's fuel and ignition systems were deliberately conservative. The engine ran cleanly, started easily in cold weather, and tolerated dirty fuel or extended service intervals better than most modern engines. Common problems were minor, intake manifold gaskets on some years and occasional sensors, but these issues rarely affected long-term reliability when addressed. Real-world mileage is where the 3800 built its name. Hundreds of thousands of Buick LeSabres, Pontiac Bonnevilles, Oldsmobile 88s, and Chevrolet Impalas have crossed the 300,000-mile mark. Many reached 400,000 miles with basic care. Taxi fleets reported astonishing reliability, and police departments favored the engine because it could idle for hours, run hot in summer traffic, and still deliver long service life. Another reason for the engine's popularity was ease of maintenance. Spark plugs, accessory belts, alternators, and sensors were accessible. Oil changes were inexpensive, and parts were cheap and widely available. The engine tolerated neglect better than most, and even high-mileage examples often ran smoothly, with minimal consumption issues. The supercharged versions, used in models like the Pontiac Grand Prix, GTP, and Buick Regal GS, added performance without sacrificing longevity. The Eaton M90 blower was simple and durable, and the bottom end had no trouble handling the added stress. The GM 3800 V6 became an American staple because it combined practicality, reliability, and low running costs. It didn't chase trends or technology for its own sake. Instead, it delivered exactly what everyday drivers needed, an engine they could trust for decades. Cummins 5.9 B Series. The Cummins 5.9 B Series is one of the most legendary diesel engines ever installed in a pickup truck. Introduced in 1984 for industrial use and adopted by Dodge for its Ram trucks in 1989, it transformed the light-duty diesel market. Before the 5.9, diesel pickups were slow, loud, and often unreliable. After it arrived, diesel trucks became known for torque, towing power, and million-mile durability. The 5.9 B Series was originally engineered as a medium-duty diesel for commercial equipment, generators, and agricultural use. When Dodge selected it for the Ram, they placed a workhorse engine into a consumer truck, and it changed everything. The engine used a cast iron block, a cast iron head, forged steel crankshaft, and thick connecting rods. Every component was oversized for the demands of a pickup. The early versions, known as the 12-valve engines, used mechanical fuel injection. The Bosch VE rotary pump, and later the Bosch P7100 inline pump, became famous for precision, durability, and the ability to run for thousands of hours with minimal wear. These pumps were simple, reliable, and almost impossible to destroy if maintained properly. With no complicated electronics, the 12-valve engines could run even in harsh environments, dirty fuel conditions, or extreme temperatures. The 5.9 produced anywhere from 160 to 215 horsepower in its early years, but the real story was torque. The engine offered a broad, flat power curve, delivering strong pulling performance at low revolutions per minute. This made towing easier and greatly reduced internal stress, allowing the engine to last far longer than typical automotive diesels. In 1998, Cummins introduced the 24-valve ISB version with electronic injection. While more complex, it still maintained the strong fundamentals of the original design. The block remained robust, the rotating assembly stayed heavy-duty, and the engine continued to deliver exceptional service life. Many owners of both 12-valve and 24-valve engines routinely exceed 300,000 miles with basic maintenance. Hundreds of documented examples have surpassed 500,000 miles, and some commercial applications have seen well over 1 million miles. The 5.9 B series was also designed with serviceability in mind. Everything was accessible, and most major repairs could be done without removing the engine from the truck. Oil changes, injector swaps, and pump adjustments were straightforward. Parts were plentiful and inexpensive because of the engine's long production run and widespread industrial use. Another reason for its reputation is its tolerance for modifications and abuse. The block can handle significant power increases without losing reliability, and the mechanical injection versions are famous for their simplicity and tunability. The Cummins 5.9 B series didn't just last a long time. It redefined what a pickup diesel could be. It brought medium-duty durability to everyday trucks and earned a reputation as one of the most dependable engines ever built. International Harvester DT466. The International Harvester DT466 is one of the most trusted medium-duty diesel engines ever built. Introduced in the mid-1970s and produced for decades, it became the backbone of school buses, delivery trucks, dump trucks, farm equipment, and municipal fleets across North America. Its reputation rests on two pillars: durability and easy serviceability. Few engines were engineered so deliberately to stay alive for decades. The DT466 is a 7.6-liter inline-six with a cast-iron block, cast-iron head, and heavy-duty rotating assembly. Everything about the design emphasized strength. The crankshaft and connecting rods were massive, the bearings were oversized, and the block featured deep cylinder webs to handle continuous high-load operation. This was an engine built for thousands of hours of heavy use, not short trips or light workloads. One of the DT466's most important features is its wet sleeve design. The cylinders are replaceable sleeves surrounded by coolant, which allows for excellent thermal control and long life. When wear eventually occurs, the sleeves can be replaced without removing the engine from the chassis. This in-frame rebuild capability made the DT466 extremely popular with fleet mechanics, who could refresh the engine in a shop bay instead of a machine shop. It reduced downtime, saved money, and extended service life far beyond most automotive engines. The fuel system was another key component of its reliability. Early versions used mechanical injection pumps that were nearly indestructible, while later electronic versions maintained the engine's reputation for durability. The DT466 was never tuned for extreme horsepower. Instead, it produced steady torque at low revolutions per minute, ideal for pulling loaded trucks and climbing hills without overworking the engine. In real-world use, the DT466 built an unmatched track record. School districts routinely ran these engines for 300,000 to 500,000 miles before considering major work. Many exceeded 1 million miles after one or two in-frame rebuilds. Municipal fleets and farms kept them running for decades because the engines rarely failed internally, even under long hours of idling, heavy loads, and difficult conditions. The engine also benefited from parts availability. Because it remained in production for so long and was used in so many platforms, replacement components were inexpensive and easy to find. Mechanics appreciated that everything was accessible. Injectors, fuel pumps, water pumps, and external components could be serviced without major disassembly. The DT466's simple, robust engineering contributed to a reputation that still stands today. It is often called the million-mile medium-duty diesel because owners expect it to last that long if maintained reasonably well. The International Harvester DT466 is a benchmark in longevity. It was designed from day one to be rebuilt, maintained, and kept on the road for decades. Few engines in any class match its combination of reliability, ease of service, and real-world lifespan. Toyota 1FZ FE Inline 6. The Toyota 1FZ FE is one of the most respected long-life gasoline engines ever built, especially among off-road enthusiasts and Land Cruiser owners. Introduced in the early 1990s, it powered the 80 series and early 100 series Land Cruisers, vehicles known for surviving conditions that break most trucks. The 1FZ FE was not designed to be light, efficient, or cutting-edge. It was designed to run reliably anywhere on the planet, while supporting vehicles expected to last decades. The engine is a 4.5-liter naturally aspirated inline-six with a cast-iron block and an aluminum head. Toyota deliberately overbuilt the bottom end. The crankshaft is thick and heavy, the connecting rods are robust, and the pistons were engineered for stability under long-term heat loads. The block features deep cylinder walls and a rigid structure to control vibration and wear. Everything inside the engine was designed with longevity rather than performance as the priority. The 1FZ FE used a dual overhead camshaft layout with 4 valves per cylinder. Even though this configuration is more complex than older Toyota engines, the components were intentionally large and conservative in design. The timing system uses a durable chain instead of a belt, greatly reducing the risk of catastrophic failure. Fuel delivery came from electronic injection, but the electronics were simple, reliable, and built to withstand heat, humidity, and dust. Where the 1FZ-FE truly earned its reputation was in the real world. Land cruisers equipped with this engine were used in regions with poor fuel quality, limited maintenance resources, and harsh climates. These engines handled extreme heat in Australia, cold starts in Siberia, high altitude in South America, and sand dunes in the Middle East. Owners frequently report 300,000 to 400,000 miles with only routine service. Many engines exceed 500,000 miles, and some well-maintained examples have surpassed 700,000 to 1 million miles. The 1FZ-FE also tolerates abuse remarkably well. Overheating incidents rarely cause catastrophic damage because the head gasket and cooling system are robust. The bottom end doesn't develop premature wear, even under heavy off-road use. The engine's large oil capacity, slow operating revolutions per minute range, and strong thermal management all contribute to its lifespan. Another advantage is serviceability. Spark plugs, ignition components, sensors, and belts are easy to access. Even in remote areas, mechanics can perform repairs with basic tools. Aftermarket support is extensive, with rebuild kits, gaskets, and components widely available despite the engine's age. Although the 1FZ-FE isn't fuel efficient and adds significant weight to the vehicle, its reliability made it a favorite in the Land Cruiser community. Many consider it Toyota's most durable gasoline engine. The 1FZ-FE embodies Toyota's philosophy of building engines for the harshest environments. It may not be the most modern power plant, but few engines match its proven ability to run for decades under punishing conditions.